Hello class, today we are going to continue to learn about systems of equations. In our previous lesson, we learned how to solve systems using the graphing method. In our lesson today, we are going to learn how to solve systems using the level 1 substitution method, and we're also going to learn how we can check our answers using algebra. In our upcoming lessons, we're going to learn levels 2 and 3 of the substitution method. Now I bet you're wondering, what are the differences between each of the levels? In a level 1, there is no additional work that we need to do in order to move from step 1 to step 2. In level 2, there is one step that we must do in order to move from one step to the next. In level 3, step 1 requires multiple steps in order to complete it and move on to step 2. In order to solve systems of equations using the substitution method, there are 5 steps. First, we must solve one of our equations for x or y. Then we can substitute its expression into the other equation and solve for the remaining variable. Once we have one of our variables' answers, we can then go back into one of our original equations and substitute our answer. And finally, we can solve for that remaining variable. So let's keep these steps in mind as we look at our next example. Here we have a systems of equations, because there are 2 equations with 2 or more variables. And looking at these equations, the second equation has y by itself, which means y is our isolated variable. So since it says y equals 6x, that means that expression 6x can be substituted into the other equation wherever we see a y. So if we rewrite the first equation and remove the y, we can substitute its expression in. Now, this equation only has one variable, so we can solve. We first have to distribute, which would give us 18x. I see we have 2 like terms on the same side. Combining those 2 like terms together give us 20x. And now we must divide both sides by 20, so we get x equals -1. Now that we have our first answer, we can go ahead and take that answer and substitute it back into one of our original equations. So I'm going to go ahead and substitute it into the second equation. That means wherever I see an x, I can replace or substitute it with a -1. Now in this equation, there's only one variable, so we can solve. Y equals -6. Now that we have an answer for y and an answer for x, we can write it as an ordered pair, and this ordered pair is our solution to this system. So if we think back to our previous lesson where we learned how to graph systems of equations, this would be where our 2 lines cross each other. They would cross at the coordinate -1, -6. So that's great, we solved the system, but first we need to check our answers before we can move on to another problem. So here are 2 equations, and we can replace the x with a -1 and the y with a -6 because that's what we found as our solution. So if I rewrite the first equation and substitute in my answers, I no longer have any variables. So what I want to see is, when I substitute in -1 and -6, does this make my statement true? So let's try and solve this. -1 times 2 gives me -2, and 3 times -6 gives me -18, and -2 plus -18 gives me -20. So my final expression here is -20 equals -20. That is a true statement. That means my ordered pair, -1, -6, made my equation true. So that's great. We've solved it for the first one, but we have to solve it for the second one to make sure it's also a solution for the second equation. So again, we can replace the y with a -6 and the x with a -1. Here I have no more variables, so I can go ahead and solve. And my expression states -6 equals -6, which is another true statement. When both of these statements come out true, that means our solution, -1, -6, was actually in fact a solution to both. This is the correct answer. Let's try another problem. This is where I want you guys to practice. So here is our system. I'm going to have you pause the video and try to solve this one by yourself. Once you've finished, go ahead and press play, looking at all of the steps to make sure you solved it correctly. Okay, let's check. Well, the second equation had x isolated, so its expression 2y plus 5 can be substituted into the first equation wherever we see an x. So we're going to go ahead and take out the x in the first equation and substitute 2y plus 5. Now our equation only has y's and we can solve. Distribute the 3, giving us 6y plus 15 minus 4y equals 17. On the left side of the equal sign, we have two like terms. When we combine them together, we get 2y plus 15 equals 17. We must subtract 15 on both sides, and then divide by 2, and y equals 1. So now that we have one of our answers, we can go back to one of our original equations and substitute it back in. So I'm going to rewrite this second equation, replacing the y with 1. When I solve, x equals 7. So your final answer would be written as 7, 1. Did you guys get it right? Great job! I'm so proud of you, and I can't wait for you guys to learn how to solve systems of equations using the substitution level 2. See you tomorrow.